All right, welcome everyone to our second Morning Bites workshop of the semester, the first of a two-part series on demystifying the command line. These two workshops have been conceived of and are being presented by Daniel Flau, who is an undergraduate in the computer science department and a linguistics minor. Daniel has been really skilled over the last several months here at kind of marrying these two disciplines, right? Kind of translating some of the techier stuff for humanists. And it's a really important position to sort of mediate between these disciplines and these fields. So we're really excited to have him here today to talk us through some of this working with the command line. Today, we're going to kind of cover some core concepts. And then in 2 weeks, we'll reconvene for kind of a hands-on workshop where Daniel will walk us through some particular commands and some sort of use cases for what this might look like, how we might use the command line for research. I also want to say that we have, after this workshop and the next, we have one final Morning Bites, which will be a research showcase with some of our undergrads working on the Schaefer project. So watch your emails for more information on that. And with that, I will hand it off to Daniel.
Thank you, Dr. Smith. Hi, guys. Thank you for coming to my talk today. Let me go ahead and start sharing my screen, and then I will also share a link. Let's see. Why? Oh, it's putting the window up on a different monitor. Hang on a second. There we go. Okay, first I'd like to verify. You guys can see my screen all right?
Yes, we can.
Yes.
All right. And then the other thing I'm going to do, this talk comes with a handout. We're not going to use the handout during this talk, but the handout basically just talks a lot about what I'm about to talk about. And so it's useful for you to take away after this talk. If you want to come back and look at this stuff that we talk about today again, but without necessarily having to consult a lengthy YouTube video. So I'll go ahead and put that in the chat. Once I figure out where Zoom puts the chat window when I'm sharing my screen. Hang on. More chat. There you go. Okay. So today's plan for what we're going to talk about today. I'm going to introduce the command line. I'm going to talk about what it is, and I'm going to give you some context for it that you don't generally find in like a YouTube tutorial or even necessarily a book on the command line. A book on the command line will brush the context that I'm going to talk about, but I want to go into it in a bit more detail because I think having a clearer idea of how the command line fits into a larger computer system sets you up for greater success down the road. It'll make the learning curve a little bit gentler as you try to transition from a beginner to an intermediate user. And then today I'm also going to demonstrate the command line. I'm just going to show off some basic commands, explain how they work. You're not going to need to memorize any of these commands. The idea here isn't to come away today with any practical skills, just with an impression of what the command line is like that's more realistic than you're going to find in a Hollywood Hollywood portrayal of the command line. And like Dr. Smith said, this is the first of two parts. 2 weeks from now, when we do part 2, we'll actually be giving you guys access to a command line on a computer we control so that we know exactly how it's going to behave from you. And you'll get to practice with some commands. You'll have the opportunity to make some mistakes. And when you make a mistake and you have a question about it, you can immediately ask us and not have to like write us an email and wait for a response and stuff like that. All right. So what is the command line? And here I will go into actually presenting so that you guys can see the text at a larger screen. Well, the first thing to know about the command line is that it isn't the command line. There are command lines, plural. Command lines are a kind of software for your computer. And just like you can get more than one calendar application or more than one painting application, you can get more than one command line. And which command lines are available to you might depend on what operating system you're using or who's administrating your computer. It might be you, it might be somebody else. I want to stress that a command line is an application that you can choose. If you find that you like one more than the other, you're going to have that opportunity to decide, where do I want to concentrate my effort on learning. So a command line is a primitive way of using a computer. And I want to stress that I'm not using primitive here as a word that's like, oh, this is something to look down upon. I just mean that this is what we had before we used graphical user interfaces. It's still used a lot today. And you'll learn as you get more familiar with the command line. You'll learn more history about the command line and see why it has such staying power. But the basic idea of using the command line is you type out a command, sort of like you would say a sentence in a natural human language, and then you submit the command. And the shell or the command line will interpret that command, figure out what it is that you mean, and then carry out your meaning. We call it a command specifically because if you were to map your commands to English sentences, usually they would be English sentences in the imperative style. Which, if you're, I think that, yeah, I can probably count on you guys to be familiar with the comparative. But basically, you're telling the computer to do something. Commands most often launch programs, applications like you're used to, that then do useful work for you. Oftentimes, those programs, as they do their work, they're going to print some output so you can see what the program did, and then they will quit, and you'll be able to start typing another command. And like I said, this is a primitive way of using a computer. It goes all the way back to the 1960s. So we're looking at about 60 years of history into this way of using the computing. And one of the reasons why it's been around for so long is because it uses text. If you're a software developer, it is so much easier to write programs that just deal with text, taking text in and working on it and then printing text out, than it is to construct a graphical user interface, which is much more time intensive. Hang on, I'm going to silence my phone because it looks like the whole world wants me right now and they can have me later. There we go. I lost the thread of what I was talking about. Yes, text. So because text is so much easier to work with, when programmers want to explore a new application or they just want to get some work done, they work with text and they don't bother with graphics. So here's a screenshot of what a command line will look like. It'll look something like this when you open it up. You can see that this is just a graphical looking window. I've got close buttons over here. I could move this window around, and there's some colored text. The text is all the same size. It's all the same font. It might have a background color sometime. Text can also appear italic or bold, but the basic idea is it's just characters that you're going to be doing with. And it will just fit into your operating system as like another window that you deal with. You can have a command line open side by side with your browser window or with a game or whatever. But if we went back a few decades, and this is actually a photograph that I took a few weeks ago, your computer would look something more like this, where the command line would occupy the entire screen. There is no graphical environment at all. It's just you typing commands and getting text back. So this is what the command line looks like when you're really just using it. But what I want to start talking about now is, where does the command line fit in a more modern environment? And to do that, first I want to cover how we tend to understand the computer right now. People's basic assumption or basic understanding of the computer is as a sort of three-layer system. You have the computer hardware on the bottom, and then on top of that, you have an operating system which works with the hardware, and the operating system has to be compatible with the hardware. And then on top of the operating system, you have applications where you do useful work, calendars to schedule things, web browsers to look at stuff, email applications to talk to other people. And you as a human user will interact with applications, and you'll also interact with the operating system from time to time when you want to open an application or close it, or you want to look at a clock or something like that. So what we're going to need to do, though, is make this a little bit more complex and add a fourth layer that's called the environment. And the idea of the environment is that it's what you think of when you normally use a computer. When you think of Windows or Mac OS, you're not actually thinking of the operating system. When you think of what Windows and Mac OS look like, you know, they have a desktop, there's icons on the desktop, there's windows. On Windows, you're going to have like the taskbar with the start menu. On Mac OS, you'll have a menu bar at the top or the dock either on the side or on the bottom of the screen. That's all the environment. And the word environment is being used here as like an environment that you work in, an environment that applications exist in. This isn't like truly accurate. When you start transitioning from a beginner to an intermediate, this picture will get more complex. But what I want to stress is that the environment is separate from the operating system. It's an user interface to the operating system. And it's possible for an operating system to do useful work without running any kind of environment at all. Web servers that serve websites, unless a human is actually working on a website, it just sits there serving web pages. And the only things that that web server talks to are other computers. And so it doesn't need an user interface most of the time. But what that also means is that there's no technical reason why a computer can't have more than one environment at a time. Maybe one person likes this environment while another person likes this environment, and the computer could even run them both simultaneously if it's a computer that's being used by multiple people at a time. That's probably an idea that you guys aren't really familiar with. You know, you're used to personal computers. You sit in front of the computer and you work on it. But a server, like I was just talking about, might have multiple people logged into it at once, and it has different environments open for each person to work on. So with that context, the idea that we have an environment, I want to point out that like these graphical environments are what you're used to, and the command line itself is also an environment, except that instead of using graphics, it uses texts. But it's like an user interface to an operating system. So I'll go ahead and get started and switch over to the demonstration part of the talk today. And this is the command line right now on my computer. I've just opened it up and I haven't done anything. And I'll explain what we're looking at right here. With the text that's printed up here is what's called the prompt. Like I said earlier, this is kind of a conversational way of using a computer, where you say what to do, the computer goes and does it and prints any output, and then you get to say what you want it to do next. The prompt text that you see here is supposed to indicate to me it's my turn to talk. And it shows me some basic information. You know, it shows me my name, because multiple people might have user accounts on a computer. If my brother Nathan had an account on my computer, which he doesn't, then he might see his name here instead. This is the name of my computer. Not very imaginative. I used to give my computers more romantic names. Now I just say what it is. This symbol, I'm going to tell you to just not worry about it. We will explain it in a little bit when it changes, but for the moment, we'll ignore it. Fish is the name of my command line. I'm using a command line called the Friendly Interactive Shell. And it's possible that I might want to use a different shell sometime. There's another one I have that's called Bash, and its prompt, I've configured it to be very similar, but still slightly different, so that I can tell the difference. Oh, over here in this command line, I'm using Fish. Over here, I'm using Bash. So now that we've got that, I'll start off by showing off one of the simplest possible commands that I could use. I'll start typing a command, and you'll notice that Fish starts giving me some options. First of all, it types my text in red, and that means that what I've typed so far, it doesn't recognize as a command. It can't figure out what that means. But it also has autocomplete. You're used to autocomplete on your phone. You know, you'll start typing out a text message and it'll offer what the next word. Fish does it does exactly the same thing, and here it's reaching into like my history of commands to see. But once I complete the command, it'll change from red to white. And this says, oh, this is something that if you run it, something interesting will happen. And if I go ahead and press enter, then I will have submitted that command, and the shell will go and interpret what it means and print the output. What I meant was I asked Fish to run a program called Cal, which, as you can probably guess, is short for calendar. And the calendar program, by default, just prints what you see here, a month view of the current month with today's date highlighted. So that's the simplest possible command, where you just start a program. You don't give the program any information at all. The program just has some default behavior that it goes and does. But that's not, I mean, that you can't do very much with that. Then you'd be limited only to starting a program. The program does something, then it quits, and you'd have no other way to control it. But we can exert more control over programs. Another program that I'm going to show off to you is cowsay, and I'll show you what cowsay does. I will write cowsay, which is the name of the program, and I'll type space, and I'll add this word, hi. And when I submit this, I get a picture of a cow saying hi. But if I change hi to something else, like how are you doing? I'll be a little bit more formal than when I was experimenting. Well, now the program does something slightly different. It gives me a cow that says, how are you doing? So there's this basic idea that you can invoke a program by typing its name, and then you can add extra information that that program gets access to, that program can use to do something different. So there are more different kinds of options that I'm going to introduce now. One of them is something a little bit more cryptic looking. I'm going to do cowsay-h, and this gets us something completely different. -h is shorthand for help. It tells the program that the user wants to know some information about it. So I get to see, oh, cowsay comes back and says, you have version 3.03. This program was written by this person. And here's some information about how to use it on the command line. And this is in a very tight notation that you guys don't need to worry about that understanding. But basically, this is the equivalent of going to a graphical application and asking for the about panel. Let's see, what have I got next? I got to look at my script here to keep track. Yeah, and I'll talk a little bit more about why it's -h. The dash is a convention that says, oh, what's coming up is going to be kind of like a user interface control, kind of like a checkbox. -h, when I say, it's like I'm checking the box that says run as a help program. But it's possible for this switch or sort of user interface element of a command line program to be a bit more complicated. So I'll start by doing a command that's a little bit longer, like this one, and run it. And here we'll see that what I've done is I've changed the eyes of the cow. Up here, the eyes of the cow were open. Now they're closed. And also, the cow is sticking out its tongue. And the reason the program is doing this is because I'm using options that cause it to do that. The -t option takes an argument, u, and that's what's being passed as, use this for the cow's tongue. The -e element then takes this value, two dashes, and uses them as the eyes. And then it interprets the rest of the things on the command line as what to put into the speech bubble. So you can see that you can use options as kind of like a checkbox. Just you turn it on or you turn it off, and that causes the program to do something. But you can also use them as like text fields almost to add stuff that can control a program's behavior more carefully. Another option is one like this. So the -f option, behind the scenes, cowsay has a bunch of plain text files that it's kind of using, and the plain text files have special place markers in them to say, oh, this is where you should put the text. And I can use the -f flag to choose the name of the file that I want to use that has the text art in it. And I can get something completely different. We typed a command called cowsay, but we're not even getting a cow back. This time we're getting a fox. Cowsay by default, I think it's -l I want, comes with a whole bunch of these. Some that I didn't even feel like really, like I don't I don't want to know what that is, but a stegosaurus might be pretty cool to look at, or an elephant. There's all sorts of things you can do. And again, I just flipped a check mark basically and said, I want you to show me a list of the files you have, and then I could start exploring with them. Now, Cavse, though, isn't really practical. The next thing I want to do is show you some commands that are actually useful. And so what I'll do is I'll switch, because I also want to illustrate how these commands can connect to the graphical world. I'll switch and have a file browser over here at the same time. And let's see. Let's start. You can see basically my home folder. You guys also have home folders. You probably recognize, let me see if I can make this larger for you guys. There, yeah, you guys probably have folders like this, documents, downloads, stuff like that. Over here, if I type a command called ls, I get a list of the same things that you see over here in my browser window. You know, I can see my applications folder, my documents folder. They're different colors. You don't need to worry about those colors yet. But you can see, like I have a picture here that's a map of my local library, and I can see that over here. I can also pass some flags to this small program that just lists the contents of a folder. If I hit the -1 checkbox, then what it does is it uses one column. If I use the -L command, and here I will have to make things bigger, I get a lot more information. I get to see like the permissions for each file. I get to see who it belongs to and the group of people that it belongs to. I get to see its file size in bytes, the last time it was modified, and then its name. And then also some of my folders are actually aliases or shortcuts to other places in my file system. And another thing, here's something cool. If I pass the name of one of my folders to the list program, then I get a list. Oh, and you do have to type things correctly. My folder is called documents and not document. Then it lists what's inside that folder. So now I asked for list the documents folder, and I get to see the things that are inside there. Another command that I can use if I'm more interested in my documents is cd. cd is short for change directory. Directory is a more technical term for folder, basically. So when I run this command, I've told my shell, move into the documents folder. And you can see now that what this part of my prompt means. It's to tell me where in my file system I am. Before, when I ran the list command, I was in my home directory, which is what this tilde is supposed to represent, just as a short form. But now that I'm in the documents folder, if I just run the list program without any arguments, now it shows me what's in my documents folder. And what I can also do is, if I'm interested in one of these files, I can use a command called cat, which is short for concatenate. And I'm not going to get into too much detail of why it's called concatenate, but I can just pass the cat program one of my text files, and it will print the contents of that folder out onto my screen. So now I can look inside this file. If I wanted to, I could print the contents of some other files. So like one of the things I do is collect sets of dice, and I have a file that's listing, the brands and the sets that I have. It's a small collection because I don't want to spend too much money yet on dice. But this is just a text file. Like I could open this file, in a graphical text editor and edit in an interface that you're more familiar with, that you've probably seen something more like before. Let's see. Another thing I can do if I wanted to. Oh yeah, what I should do here is I should switch over to a workspace where we can do some more installs. So what I'm going to do is change to another folder on my computer. And I'm using 2 dots up here. The 2 dots mean I should go up a folder. I'm in my documents folder. That's going to tell the change directory command to go up to my home folder, then go into my projects folder, then go into the experimental folder. And I'm going to delete this real quick because that's not supposed to be there. So I'll go ahead and do that. And now if I type lists, you can see there's nothing over here. That folder is empty. Well, what if I want to create a folder from the command line? I can use the make directory command. So I'll go ahead and type what I was going to have, which was the command line brown bag. And you can see as soon as I typed that command and the directory was created, right over here in my graphical application, that appeared. And now I can go ahead and switch into that directory, and I'll do that here. And again, it's empty. There's nothing here. So I've showed you so far how to list, where you are in the file system, how to move into different folders, how to get the contents of files. What if we want to create a file? Well, the simplest way to create a file is a command called touch. And I'll go ahead and just do touch test.txt file. And now I have created a file. Size 0 bytes. This is a blank file. There's nothing in it. So that's not very interesting. Let's say I wanted to get rid of that file. Then I could use the remove command. Now it's gone. And if I wanted to actually, make a file that has something in it, I could open let's see, what's the name of this that I'm going to use? Example.txt. I could use a command called nano. Nano is a very, very simple text editor, and it's different from the commands that I've showed you before. The commands I've shown you so far, you run them, they do something, they print output, they quit, you run another command. But nano is different. Nano takes over the command line, and it becomes this interactive program where I can start, actually working on a text file. I can type stuff out. I can move my cursor around. This looks a lot like a traditional text editor that you might use graphically. Down here, it's giving me a kind of a cheat sheet to show me, like, these are the commands you could do. If I wanted to cut or paste, there are commands that I can use to do that. I'll expand my shell real quick. There are also commands for saving the file. I have a command to quit. These are basically just keyboard shortcuts that I could use to execute these things. That's the thing about the command line, is you don't really get the mouse. So everything has to be done through the keyboard. So once I'm done, I could go ahead and type the keyboard shortcut to quit, and it'll say, hang on, you haven't saved your file. Are you sure you want to quit? And in this case, I'm going to go ahead and say, actually, yeah, I'm going to say yes. So let's see. So now my file is there, and if I cat it, we can see, the junk that I wrote into that. I also have commands. Real quick, I notice I'm already halfway through my time, and I've got more stuff I want to talk about. If I wanted to, I could create a copy of this text file. And here I'll go side by side again. I could use the copy command, where it takes two files. I'll say I'm going to copy example.txt to backup.txt. And now you can see I have example and backup.txt. And if I open them both, I got a tabbed interface. They both contain the same text in them. Let's see. And then I could also move a file or rename a file. I could move example.txt to another example.txt. And you'll see over here that the file gets renamed. So yeah, let me just summarize the commands that we've looked at so far. We've looked at commands that show you what's in the folder that you're in, commands that let you change where you are in your file system, commands that read out the contents of files, commands that create files, commands that edit them, commands that remove them, copy them, rename them, all just sort of basic stuff that you'd be used to doing in your operating system's file browser. On Mac OS, that's called the Finder. On Windows, I believe it's called a File Explorer. But I haven't really shown you any kinds of the overarching features that the command line has. On Windows and Mac OS, you have things like the taskbar, the start menu. You have things like the menu bar that lets you do things like change between applications. You can also move applications around, switch between them. And what I want to do is show you now some parts of the command line that are like those overarching features. And two of the ones that are most important are called redirections and pipes. So suppose I had this command like this, list-l. I showed you this one before. It just lists all the files in the directory where you are with lots of information. If I want, I can use an overarching feature called redirection to, what's the name of the file that I want to put this in? File listing.txt. And you can see I've got this sort of special color going on now. The shell is, the command line is using this to show me, oh, you're about to do something special. And when I run this command now, instead of the list program printing out what it said before, it saved it to a file. And now if I use the command that I used before to read out the contents of a file, we can see what's in it. And you'll notice when I started running the command, the file was created, the shell created the file immediately, and then it invoked the list program, and the list program went and it saw, oh, there's a file listing.txt, and there's nothing in it. But then, the list actually went ahead and printed out its contents, and that got saved to the file. And so now, if I were to list -L again, we would see that the file listing.txt has become 168 bytes in size. If you're not really following along with me, that's okay. This is one of the things that makes the command line harder for people, is because it's a lot of stuff happens behind the scenes, and you don't necessarily get to see it. So if you're not following along with what I said, don't stress out about that too much. Remember, I'm just giving you an impression today of the command line. I'm showing that it has parallels to the graphical environments that you're familiar with, and that it has overarching features. With the one that we just talked about is redirection, where you can take the output that a command does, and you can redirect it from going onto the command line screen to going into a file. Another kind of feature that's very useful is called piping. And before I show it off to you, I want to show you a new command I haven't shown you before. It's called random. If I just run random with no options, I get a random number. If I run it repeatedly, I get different random numbers. I think its default range is somewhere from 0 to 10,000. Oh, no, it can go above 10,000. Probably it goes from 0 to 32,000. But if I wanted, I could, of course, redirect those numbers to a text file. And I'll go ahead here and I'll open this text file. I'm going to use a particular code editor, text editor that I like. You can see I saved a random number to this file. If I reran that command, where random chooses a number and sends it to the file, you can see that the number gets changed in the file as I go along. But maybe I don't want to completely replace the file. Maybe instead of just writing to the file totally, I'd like to append to it. I can do that by adding another chevron. And now, as I repeatedly run the command, I start adding stuff to the file. And here you start to get an idea of, oh, how I might start using this for more practical purposes. If I want to create a workflow that involves, working with information, and maybe I want to take information from different places and summarize it in a file, this might be a way to do that. But there's another command. I still haven't introduced pipes yet, I'm sorry, but I want to show you, called sort. And what sort does is, if you give it some stuff, and notice I passed a command option in what's called a long format. Before, you've seen me pass options with one, but if you use 2 dashes, that's a convention that says, oh, there's going to be an option whose name is longer than a single letter. And so you can say, so you can plainly read this more easily now. I'm going to sort something, and it's pretty obvious I'm going to do a numeric sort. So I'll go ahead and I'll put in some numbers. They're clearly not in increasing order, but once I've done that, sort will take them and it will print out the sorted version of those. And of course, I could go ahead and take that and I could have saved those to a file. So if I do numeric sort to and put it into numbers.txt, I can go ahead and enter a bunch of numbers. They don't necessarily have to be in order. And then when I'm done, it doesn't print the output, because instead that got saved to a file. And if I read out the contents of the file, it's the numbers that I typed that are in sorted order. So why I'm introducing these commands, random that generates numbers, and sort that sorts numbers, is I'm going to introduce this feature called pipes. And I'll type a command like this. I will cat random.txt. Oh, that's like, it was in my history, so I didn't even have to type it all the way out. Fish just suggested it to me. The pipe looks like this. This is called the pipe character. And what it does is it takes the output of one command and feeds it as input to the next command. So in random.txt, we have these numbers that were generated by the random command, and we save them to a file. And of course, they're out of order. But what we're going to do is feed them into the sorting program. And then we're going to combine that with the redirection feature that I showed you and have it output them to sorted.txt. So I'll show you. So far, the files that we have are numbers.txt and random.txt. So this is going to create a new file that we haven't seen before called sorted.txt. And I'll go ahead and I'll run this command that's going to take the numbers out of random, sort them, and put them into sorted.txt. And we'll see that file gets created. And if we open it, we have our files. That's kind of tiny text. Can I make this bigger? No. I'll use this. There we go. You can see that those random numbers that were generated in random.txt have now been put into the sorted.txt folder. So I'll pause sort of at this point where I've introduced basic commands. I've shown you how to move around the file system, and now I've shown you some overarching features that allow you to make much more complicated sentences than just starting a program and giving it some options. Because here I started 2 programs and linked them together. I want to ask if anybody has any questions or anything, if there's anybody who's sort of falling behind and would maybe like me to clarify something. Okay, so if one of you is typing a text chat message, I'll keep an eye on it, but I'll keep going ahead. And I'm going to move on to the most complicated part of this talk. I'm going to talk about what's called scripting. Because so far, we've been using the shell as an user interface, a way for you to use a computer to do stuff. But one of the most powerful potentialities of the command line is to use it not as a way to use a computer interactively, but as a programming language where you can write a program and then save that program to a text file and then run it over and over and over again. And usually these programs that you would write are not very complicated. They do something that's like really specific that saves you time that nobody else in the world would necessarily find useful. And what I'm going to do is show you a program that I wrote while working with the command line to do a task just like that, that was very specific to me, but not useful to other people. So what I'll do is change to where I keep it. So I created this script, and I call it the Remix Icon Processor. And I need to give you a little bit of background here. I'll switch to my browser. Remix icons. So there is a set of icons that I love. It's my favorite set of icons in the whole world. The website's a little bit heavy. I gotta wait for it to come up. But basically, it's an icon set, a very large one, a very high quality one. There's more than 2,000 icons in it, and they're all beautifully consistent in their appearance. And what's really nice about these icons, is they're in a format called SVG. And this isn't a talk about image file formats, but basically the thing to know about SVG is it doesn't use pixels. It uses mathematical descriptions of lines and curves so that you can take a scalable vector graphic, that's what SVG stands for, and you can make it as large as you want, and it will never pixelize. And so the website that the Remix icon set has is really nice. You can pick an icon that you want. You can choose a color for it, a size for it. You can get it as an SVG. You can get it as a more common ping file format where it does use pixels. But one thing you cannot do is download all of the icons in a specific color at a specific size. It's possible for me to say, oh, I want maybe this small group of icons, and then I can go over here and choose a color and choose a size and download them all in that. But if I want the entire icon set in a different color, I would have to spend a lot of time going through each of these icons saying plus, 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 plus. It would take forever. Well, it wouldn't take forever. I think I did some math. It would take me about an hour and a quarter, assuming it took me 2 seconds for each icon. I don't want to spend time doing that. I want to spend time doing more useful work. So what I could do instead is download all the icons, and when I do that, I get them as here. I'll show you what they look like. I need community remix icon. I get them as SVGs, and they come in the black color, and that's what I get. But I don't want them in the black color. What I wanted at the time was I wanted them in a lot of different colors, and I also wanted them at a lot of different sizes. So once I have this file, I could open it in an image editor, and I could spend time manually recoloring it, manually resizing, but that again would take forever. So what I decided to do was use the command line as a scripting environment, a place to write programs that would do this work for me, because there are commands that I can use that can recolor an image, that can convert an image from one file format to another, that can resize an image. And so instead of me manually doing all that work or spending tons of time on the website changing the colors of things, what I could do instead is write the commands that do those and structure them in such a way that the computer does all of that hard work for me. So I haven't given you any idea of what this actually looks like, and I notice we're almost 3/4 of the way through, so I'm going to try and be brief. The first thing go ahead, Dr. Hildebrandt.
Yeah, no, I was just saying we are 3/4 of the way through our time, but we also did want to leave a minute or two at the end for questions. And also just keep in mind that actually both Meg and I we'll have to close this at 11 o'clock because we both have other meetings. So anyways, keep on going.
Yep. All right. So real quick, I'll show you one of the simplest possible scripts. And like I've been talking about, writing a program and saving it to a file. I won't even do that yet. What I'll do is I will take a small kind of script called a function. And let me see here. I would like to, by the way, here's a command called code. And when I do that, it opens the text editor that I normally use to do all my stuff in. But I'll show you real quick. This is the whole script that I'm going to introduce to you. I'm not going to go into it in too much detail, but I'm going to start by introducing this concept of a function. And a function is kind of like a mini program that I could write. This function that I've written, what it does is it checks for a dependency. My program needs a command called SHAML to work, and I wanted to make sure, someday I might move from one computer to another and want to use this. If I don't have this command called SHAML installed, I just want my script to tell me. But what I'll do is I'll go ahead and take a function much like this one, and I slightly modified it in my script to basically do what this function does, but do it interactively here. And let's see. What I do is I've typed this out on the command line, and you'll notice the command line has behaved differently now. Instead of me writing one line of text and then submitting it, it's actually let me type multiple lines. And the reason it's done that is because the function keyword causes the shell to do stuff slightly differently. You don't have to worry about what this code does because I'm about to illustrate it. So I've just defined a function. If I opened, Zoom is in the way. Hang on, I gotta get it out of the way. If I opened a different shell where I hadn't just done that, because unfortunately I wasn't thinking and I did things out of order. Give me a new time. If I tried to run this function, if I start typing out the name of that function, you'll notice it's in red. It doesn't exist. If I return it, Fish will say, I could not find that command. But over here in this command line where I did type it out and submit it, now if I start typing check for SHAML, you'll notice it's not in red anymore. Over here, I've entered this function. I've created this block of code that is, it's commands. It's some commands that I haven't, introduced to you yet, but I've defined it. And now if I run it, it will say, yay, SHAML is available. because I wrote in my function a command that tests to see if SHAML exists, and that will echo text based on whether it's there. If I went ahead and ran the command that I need to run to remove SHAML, so let's see, that's cdnf remove. This is a command that's going to uninstall software from my computer, and because I'm doing something that requires privileges on my computer, I'm going to need to type out my password carefully. There, go ahead. So I went ahead and I just uninstalled SHAML, and now if I run that function, you'll say, "Oh, your SHAML is not there." And then I also started writing the script. And I was like, "Oh, maybe I'll share this with somebody. I should probably like explain stuff in my error messages." So I went ahead, and you can see if we look at the code for the function, I've got an error message that was just typed out. But I'll go ahead because I'm going to need that SHAML command again. So sudo dnf install SHAML. Thank you. Yes, I really want it. All right. So the idea was I just defined what's called a function, a little miniature program where I can type a bunch of commands, and I also get some other structures that I can use, if, like to test if something is true or false, stuff like that. And then I have that command defined, and I can use it as a sort of shorthand for stuff that I'm going to do. What I'm going to do now is show you what it looks like when I run this script that I prepared. And what it's supposed to do. Let's see. I need to go to personal asset remix icon processor. What it's going to do is take all the icons. Actually, I can delete this. It's going to take all the icons that I got in this one file format at this one sort of non-size. SVG can be any size, that are in the black color, and it's going to generate them for me in different sizes and different colors. And let's see, the first thing I should do is come over here and invoke -J, and I'm going to do rasterize one, and I'll show you the text that I just wrote out. The name of my program is stored in this file. It's processicons.fish. That's this text file over here that has all this code that I wrote. And I'm passing it some options that I defined. One of them is -J, and that refers to another file that I can write. If I open that file, I basically created my own quick little file format that contains information about what to actually do. This is going to take my SVG files and it's going to rasterize them. That means basically convert them from one format to another. And I'm going to, I've created like these batches where it's going to create them in different sizes, specifically in a size 16 pixels large and a size 24 pixels large. And if I go over here and I execute this command, we can see in real time each one is being converted from the SVG format that it was to a ping at different sizes. And it takes some time. You know, we can see it's doing, you know, each icon one at a time, and it's taking enough time, you know, that I have to wait around for a few minutes. But while I've got that running in run window, it's possible for me to open another window side by side, and I could do multiple job files at a time. And so now over here, I asked it for two batches, one that's going to do them at 16 by 16 pixels and 24 by 24 pixels. This job over here that was a different job file that I specified is going to be at 32 and I think 40 pixels. We're just about running out of time. But the basic gist here is that I was able to write a program that uses commands like I've shown you so far. There are commands that are used to actually do stuff. So for example, I've created commands that are going to be responsible for making directories that mirror the folders that I get all the icons in. There are little programs that I've written that do things that do the actual work. For example, this is a command that I had to write, and you can see it's it's quite involved, or it looks quite involved. But what it's doing is it's going through a file and figuring out how to recolor it. But the idea basically here is to take that conversational mode where I can write commands that maybe convert a file from one format to another and express logic and say, oh, I want them to be converted to this color, and I want you to rename the file this way, and I want you to export it into a specific place. Again, I want to stress that you guys don't have to understand all that's happening here. The thing to take away is that you can do this stuff where you can have a conversation with the computer. You can compose, you can sort of write almost natural language like sentences that instruct the computer to take different programs and string them together. You can use those same commands. You can put them into programs that take other people's programs and sort of glue them together repeatedly. You can use this to do all sorts of stuff. And 2 weeks from now, we're going to put you guys in a command line environment, and we're going to walk you through a use case. Right now, what we're thinking we're going to do is take some books that are in the public domain, and we're going to analyze how punctuation is used by different authors, by different kinds of books. And we're going to use the command line to help us explore that. We're going to write commands that go through a book and remove all the words and leave just the punctuation. We're going to look at commands that like count up how many periods are there, how many commas are there, what's the sentence maybe that has the largest number of commas in it. So like if we take A Tale of Two Cities, I think we're going to be able to expect that first sentence to have just a ton of commas, and our program would come back and say us, oh, The Tale of Two Cities' longest sentences has like 24 commas in it. So like I said, the thing to take away today is just an impression. You don't have to remember the technical specifics, and we're going to put up a blog post about this on the IRIS website. You're going to be able to come back and rewatch this if you want. There's going to be the slides to download if you wanted them. There's also a handout that's that goes into what I've just talked about a lot. Not so much the demonstration stuff, but the concepts that we talked about at the front, and it'll be there for you to review if you want in 2 weeks when we go to give you guys more hands-on experience, so that you hopefully you might be feeling overwhelmed now, but 2 weeks from now, after you do the workshop, you'll have a better grasp on things. With the last 5 minutes, I'll ask if anybody has any questions they want me to address real quick. Ooh, that could mean either that I just gave a really good talk or a really bad talk. Well, I'll find out, I'm sure.
I know that as you were introducing some of these commands, Daniel, I was going over to Google and looking them up to learn a little bit more about how they work. And for example, the random gives you a number between 0 and something like 32,700 and something. So yeah, those are kind of, I think those are cool ways to introduce people to the idea of the command line.
Yeah, and another skill that we will cover in the next 2 weeks is not just, these are some specific commands that you can use in this specific case. I will also be, introducing you guys to ways to actually explore the command line. Like you have some tasks that you want to do and you don't know what the commands are to do it. How do you go about doing the research to find out how to do that? And we will cover that in the next 2 weeks.
So yes, if people, oh yeah, go ahead, Daniel.
Oh, and the last thing that I want to mention for people who are here right now is that the handout that we're going to upload to the blog post on the IRIS website also includes some book recommendations. There's a book for people on macOS, a book for people on Windows who maybe want to go deeper into this on their own time and want a more structured introduction. So just to get you started, you don't even have to wait 2 weeks if you don't want to. You'll be able to get that handout off iris.siue.edu/workshops. And there's a way to get more information there.
Thanks for that. So for those of you who attended today, if you're not too terrified by the exciting prospects of the command line, we would love to invite you to join us again in 2 weeks for an actual hands-on. So I'm looking forward to that as well. So I think that we'll wrap things up for now. Again, join us in 2 weeks if you are interested. Is there going to be a separate registration link set around, Meg, for that one?
It's the same registration link. So if you're registered for this one, I believe most people are registered for the second one as well.
Okay.
So.
We'll send another announcement out though for if people want to join us, other people want to join us. Thanks again, everybody, for making time today. And if you're watching the video after, I hope that you're learning some interesting new things, getting under the hood, so to speak, of our computers in ways that we probably hadn't thought about before. So thank you very much, Daniel, for presenting this. This is amazing. And
no problem. Thank you for
really
having
value
me.
your knowledge. And thanks also, Meg. And I hope everybody has a lovely day, a lovely weekend.
Thanks, everyone.
Bye-bye.